Right now, in facilities across 3 continents, engineers and scientists are building the actual physical infrastructure that will determine whether humanity survives the next 200 years. And almost none of it is making headlines. This is not a prediction about the future. It is a description of what is actively under construction, actively being tested, and actively being funded at a scale that has no precedent in human history. The convergence of technologies being developed simultaneously right now, in space access, artificial intelligence, clean energy, biotechnology, and planetary defense, represents the most compressed period of civilization-altering engineering ever attempted, and the decisions being made inside these programs in the next decade will lock in trajectories that future generations will live inside for centuries. Start with space. SpaceX's Starship, the most powerful launch vehicle ever built, is in active flight testing with a fully reusable architecture that could reduce the cost of reaching orbit by a factor of 10 or more compared to previous generation rockets. When launch costs fall that dramatically, everything changes. Space-based solar power, collecting solar energy in orbit where the sun shines continuously without atmospheric interference, and beaming it to Earth as microwave energy, transitions from theoretical concept to potentially economically viable infrastructure. The European Space Agency and the United Kingdom's Space Energy Initiative are actively studying and funding space-based solar power development, with the UK government committing research funding toward feasibility assessment for a system that could deliver gigawatts of continuous clean power to Earth's surface. NASA's Artemis program is simultaneously building the foundation of a permanent human presence beyond Earth. The Lunar Gateway space station, developed in partnership with ESA, JAXA, and the Canadian Space Agency, is designed to serve as a staging point for lunar surface operations, and eventually as a waypoint for crewed Mars missions. The first Gateway modules are in production. Crews have been assigned to Artemis missions. This is infrastructure being physically assembled right now. On Earth, the clean energy transition is accelerating at a pace that was considered optimistically ambitious just 5 years ago. Global solar power capacity additions in 2024 exceeded 400 gigawatts, a single-year installation record that surpassed every previous year combined in some regional markets. Battery storage capacity is scaling alongside generation, with grid-scale installations growing at rates that are restructuring electricity markets in real time. The International Energy Agency projects that renewable energy sources will account for almost 50% of global electricity generation by 2030, a target that seemed unreachable a decade ago. Nuclear fusion, the process that powers the sun, is moving from laboratory demonstration toward engineering reality faster than at any point in history. In December 2022, the National Ignition Facility at Lawrence Livermore National Laboratory in California achieved fusion ignition for the first time, producing more energy from a fusion reaction than the laser energy delivered to trigger it. This was a scientific milestone 60 years in the making. Private fusion companies, including Commonwealth Fusion Systems, TAE Technologies, and Helion Energy, have collectively raised billions of dollars in investment funding and are targeting demonstration reactors within this decade. Helion Energy has a contracted agreement with Microsoft to deliver fusion-generated electricity to the grid by 2028, the first commercial fusion power purchase agreement in history. Artificial intelligence is accelerating every one of these fields simultaneously. AI systems are now designing novel protein structures for medical applications, optimizing rocket engine combustion parameters, identifying patterns in climate data that human analysts miss, and running materials discovery simulations that compress decades of laboratory research into months of computational time. The rate of scientific progress in fields connected to AI assistance is measurably increasing year over year. Planetary defense, humanity's first serious attempt to protect civilization from asteroid impact, became operational in a new way in September 2022, when NASA's DART spacecraft successfully altered the orbit of the asteroid Dimorphos by colliding with it intentionally. The orbital period of Dimorphos changed by 33 minutes, significantly more than models predicted, confirming that kinetic impactor technology works at operationally relevant scales. NASA is now developing the Neo-Vigilant Survey Telescope, and the ESA is building the Hera mission to study the DART impact site in detail, building the knowledge base for defending Earth against future threats. Each of these programs, space infrastructure, clean energy, fusion power, artificial intelligence, planetary defense, is being built in parallel, funded simultaneously, and staffed by the largest concentration of technical talent ever assembled across human civilization. They are not competing with each other. They are compounding. Progress in launch technology accelerates space-based energy research. Progress in AI accelerates materials science for fusion. Progress in clean energy buys time for the deeper transformations to complete. The future of humanity is not coming. It is being welded, programmed, launched, and tested right now, in buildings you will never visit, by people working on problems whose solutions will outlast everyone alive today. The only real question is whether the political will, the funding continuity, and the international cooperation required to see these programs through will hold long enough for the technology to deliver what it is capable of delivering. So tell me in the comments, which of these programs do you believe is the most critical for humanity's long-term survival, and which one do you think is most at risk of being underfunded or abandoned before it reaches its potential? Follow this page right now if you want to stay informed about the breakthroughs that are actively building the next chapter of human civilization, because this is the most important story happening on Earth, and we cover it every single week.